So in the second half of this module, we're going to talk about ways to analyze aerial or polygon data. Now, the first question is, why might we want to do that? Why would we use aerial data? And the first reason is that data are not always available in point format. So some data, like census data, come only in polygon format. So you can only get the census data at the county level, the block group level, or blocks, things like that. The second reason is that some GIS operations require that the data be in polygon format. So the tool or the technique physically won't work unless the data are in polygon format. For data that aren't already in polygon format, you may need to convert your points to polygons. So this map is the tornado map, where every dot is a tornado that occurred in the US. But what if we wanted, instead of the dots themselves, the points, what if we wanted a count of the number of tornadoes that happened in each county in the US? So underneath the point map, we have a county map for every county in the US. Now you can run a simple spatial join to turn the points into a count of the number of points within each county. So instead of doing an attribute table join where you're joining attributes from one table to another, in this case you're physically joining the points to the polygon layer based on whether or not they fall inside a county boundary. So after you run that spatial join, the resulting map here looks quite different, where now for every county in the US, we have a count of the number of tornadoes that ranges from the lower end in yellow up to the higher end in the brown colors. So what are some differences between the point map and the county map, or the points that we analyze versus the counties that we can analyze? The first difference is that with the points, what we were primarily interested in was their location. So with the mean center, the convex holes, operations like that were performed solely on the points based on their locations. Now that we have the data in a polygon format, we're interested in the locations of the polygons, of course, but we are interested also in the attributes of those polygons. So the attribute now for each county is the number of tornadoes that occurred within that county boundary. So once you have data in polygon format, there's a few different types of aerial or polygon analyses that you can complete, and they kind of fall into three broad categories. So the first are overlay analyses. These you went over in GIS311, so we're not going to spend a lot of time in this class reviewing those operations. The second broad category are techniques that help you identify the characteristics of a distribution. Now, these are much the same as the ones that we went over in the first half of this module, operations like mean center and a standard deviational ellipse. You can also run those operations on polygon data. And what happens is that the analysis actually runs based on the centroid of the polygon. So it takes your polygon and it basically turns it back into a point where the point is the center of that polygon, and you can compute the exact same statistics that you did in the first half of this module. The third category here, describing spatial patterns, is what we're going to focus on in the rest of this module. So this is going to help us figure out where clusters or hotspots of activity are happening based on the polygon data. So if we take another look at the polygon map here, we can ask the question, where are the hotspots of tornadoes? Where are there clusters of high numbers of tornadoes? You may have heard areas in the Midwest referred to as Tornado Alley or Dixie Alley down south. And if we look at this map, we can start to see some clusters of higher numbers of tornadoes per county shaping up throughout the center of the country and also along the Gulf Coast and over near Florida. So visually, we may be able to take a map like this and identify where we may think some hotspots of tornadoes are happening. But what happens if we change the symbology? So this is the exact same data being displayed 4 different ways using 4 different techniques, geometric interval, equal interval, natural breaks, and a manual classification. And you can see that it very much changes where we might say the cluster of tornadoes is, or the clusters of tornadoes are across the US. And so as we launch into the next part of this module, I want you to keep a few things in mind. The first is that humans aren't very good at visually identifying clusters on a map. And part of the reason is that the symbology or the symbolization can alter our perceptions of where those clusters lie. And so statistical operations can provide a less biased method for identifying clusters. So in the next part of this module, you will learn some statistical techniques that you can implement in GIS with polygon data to identify clusters in data and search for those patterns that may be in your data. So you can read through the recap on this page and then continue on through the rest of the module.